In this video, we will be discussing the realization of parallel realization of IIR filters. In the previous video, we have seen DIR1 form and DIR2 form, also cascade form of realization. In parallel form of realization, the function h of z should be in the form of h1 of z plus h2 of z plus h3 of z and so on up to n transfer functions. The question given is obtain a parallel realization of the following system function h of z is equal to 1 plus 1 by 4 z inverse divided by 1 plus 1 by 2 z inverse into 1 plus 1 by 2 z inverse plus 1 by 4 z raised to minus 2. By applying the since this is in the form of irreducible rational function, we have to make it we have to simplify this function by applying partial fractions. By applying the technique of partial fraction, we get h of z is equal to a is divided by 1 plus 1 by 2 z inverse plus b z inverse plus c divided by 1 plus 1 by 2 z inverse plus 1 by 4 z raised to minus 2. For further simplification, we equate the partial fraction form and the rational form together and also take the LCM. When we take the LCM, the denominator on the LHS and RHS gets cancelled. By multiplying the constant terms with the polynomial and also equating the constant and the z inverse terms, we get the value of a, b and c as a is equal to 1 by 2, b is equal to minus 1 by 4, c is equal to 1 by 2. By solving the equation 1, 2 and 3, we get the value of a as 1 by 2, b as minus 1 by 4, c as 1 by 2. Let us substitute the value of a, b and c in the h of z equation. We get the complete transfer function in the form of z inverse. Let us assume this as h1 of z and this as h2 of z. In parallel realization, we know that there should be common input point and common output point. Let this be a common input point x of n. The first function h1 of z is 1 by 2 divided by 1 plus 1 by 2 z inverse. We have to put this in the form of dir2 form. The maximum delay point is z inverse. Let this be a maximum delay point, that is z inverse. In the numerator we have 1 by 2. This is 1 by 2. In the denominator 1 plus 1 by 2 z inverse. 1 and plus 1 by 2 becomes minus 1 by 2. This is our h1 of z. In h2 of z, we have minus 1 by 4 z inverse plus 1 by 2. The maximum delay point, we can see that z raised to minus 2. Hence 2 delay terms, z raised to minus 1. In the numerator we have minus 1 by 4 z inverse plus 1 by 2. This will be 1 by 2 and minus 1 by 4 z inverse. This is our numerator. In the denominator we have 1 plus 1 by 2 z inverse. 1 plus 1 by 2 z inverse becomes minus 1 by 2 and plus 1 by 4 z raised to minus 2. Since it is negated, it becomes minus 1 by 2 z raised to minus 2. And after summing up these points, we get a parallel realization y of n. The question is given as h of z is equal to 8z cube minus 4z square plus 11z minus 2 into z minus 1 by 4 into z square minus z minus 1 by 2. We want this equation in the form of z inverse. Hence we divide the equation by z cube. Dividing numerator and denominator by z cube, we get 8 minus 4z inverse plus 11z raised to minus 2 minus 2z raised to minus 3 divided by 1 minus 1 by 4z inverse into 1 minus z inverse plus 1 by 2 z raised to minus 2. Since the transfer function h of z is in the form of irreducible rational form, we have to apply partial fraction to reduce it to simpler form. By applying the concept of partial fraction, we get h of z is equal to a is divided by 1 minus 1 by 4 z inverse plus b z inverse plus c divided by 1 minus z inverse plus 1 by 2 z raised to minus 2 plus d. Since the numerator terms has raised to 3, therefore there should be 4 different variables a, b, c, d. To simplify these partial fractions, we have to take the LCM in the denominator and solve the transfer function as follows. By taking the LCM, we get a into 1 minus z inverse plus 1 by 2 z raised to minus 2 plus b z inverse plus c into 1 minus 1 by 4 z inverse plus d into 1 minus 1 by 4 z inverse into 1 minus z inverse plus 1 by 2 z raised to minus 2. In the denominator, there is the LCM on both sides, LHS and RHS. This is the given transfer function. The denominator gets cancelled. Hence, equating the numerator, the constant terms and the constant terms in the LHS and constant terms in the RHS are equated. We get a plus c plus d is equal to 8. By taking z inverse common, we get a minus b plus c by 4 plus d into 5 by 4 is equal to 4. By equating z raised to minus 2 terms in the LHS and RHS, we get a by 2 minus b by 4 plus d into 3 by 4 is equal to 11. By equating z raised to minus 3 terms from LHS and RHS, we get minus 1 by 8 into d is equal to minus 2. We get d is equal to 16. Substituting the value of d in equation 1, 2 and 3, our 4 equations get reduced to remaining 3 equations. Substituting these equations in the calculator, we get the value of a, b, c and d as a is equal to 8, b is equal to 20, c is equal to minus 16 and d is equal to plus 16. Substituting the value of a, b, c and d in the equation a, we get h of z is equal to 8 is divided by 1 minus 1 by 4 z inverse plus 20 z inverse minus 16 divided by 1 minus z inverse plus 1 by 2 z raised to minus 2 plus 1 by 16. This is our h of z. Here we can assume this as h1 of z, this as h2 of z, and this as h3 of z. We have to plot the parallel realization. In parallel realization, all the three transfer functions h1 of z, h2 of z and h3 of z must be in parallel. That is, all the transfer functions should have common input and common output point. Let us assume this is our input point x of n. This is our h1 of z. 8 is divided by 1 minus 1 by 4 z inverse. Individual transfer function should be in the dir2 form. To plot the dir2 form, this is a summation point. The maximum delay in h1 of z is z inverse, that is one delay point, z inverse. In the numerator we have only 8. We know that numerator will be on the right side and denominator on the left side. This is our numerator. In the denominator we have 1 minus 1 by 4. This is 1. Denominator gets negated, it is minus 1 by 4. Hence we write plus 1 by 4. And this is our h1 of z. In h2 of z we have 20 z inverse minus 16. In dir2 form, the maximum delay unit in the h2 of z is z raised to minus 2. Hence 2 delay units are taken. In the numerator we have 20 z inverse. This will be 20 z inverse minus 16. And this is the summation point for numerator. In the denominator we have 1 minus z inverse plus 1 by 2. 1 minus z inverse becomes plus z inverse, and plus 1 by 2 becomes minus 1 by 2, and the summation point. This is our h2 of z. In h3 of z we have only one term, 16, and this together forms output y of n.